Welcome to This Explainer. Today, we're going to peel back the layers on what honestly might be one of the biggest misconceptions in artificial intelligence right now. We're taking a super analytical, objective look at AI safety, and specifically, we're dissecting an architecture that some of the biggest tech giants are literally banking their futures on. I'm talking about multi-agent systems. Now, the prevailing logic in the industry is kind of simple, right? More bots equals more safety. But as you'll see, we're going to examine why that assumption might actually be resting on a fundamentally flawed foundation. So let's dive right in and confront the big question driving today's analysis. Does adding more AI agents actually make a system safer? There's this incredibly popular assumption right now that if you have one AI generating an output, well, you can just spin up a second, a third, maybe a fourth AI to check its work. And boom, suddenly you have a perfectly safe, highly reliable system. But treating safety like a simple numbers game completely misunderstands the very nature of large language models. Honestly, it's kind of like assuming that if one person doesn't know the way out of the woods, a group of 5 lost people definitely will. It just doesn't work that way. The research we're looking at lays it out incredibly bluntly. To quote the source, LLM-based multi-agent safety is not solved simply by adding a more sophisticated safety evaluator. What this material makes crystal clear is that current models really only offer probabilistic general safety. They give you a pretty decent guess at what might be safe most of the time. But a probabilistic guess, that is absolutely not a reliable guarantee, especially when the stakes are high. To understand exactly why multiplying these evaluators doesn't solve the core issue, we need to look at the first big foundational flaw in these systems. And that brings us to our first limit, output instability. Now, it is really important to clarify here that LLMs aren't just universally unstable. If you give an LLM a highly structured, quantitative task, say solving a rigid math equation, it acts like a rock. It produces incredibly consistent, stable outputs. But safety is almost never a math equation, is it? Safety relies almost entirely on qualitative judgments. And in the qualitative realm, there's just no single fixed answer. It's way more chaotic. For the exact same prompt, an LLM's interpretation can wildly fluctuate from run to run. It can sometimes even spit out completely contradictory judgments based on just a tiny change in temperature or phrasing. It's inherently unstable. And this instability, it triggers a really dangerous chain reaction. Step 1. If the output itself changes every single time you run the model, well, that immediately leads to step 2, evaluation target instability. The very thing you're trying to evaluate keeps shape-shifting. And if you can't even lock down the target, you inevitably crash into step 3, which is the evaluation reliability problem. I mean, you simply cannot trust an evaluation if the baseline is constantly moving. Running a moving target through 5 different AI agents doesn't magically fix the instability. It just multiplies the noise. And this unreliability brings us straight to our next major hurdle, which is our second limit, missing references. The source draws a brilliant, absolutely critical distinction right here. On one hand, you have general danger and safety. These can largely be defined by universal rules. Building a bomb? Universally dangerous. We can all agree on that. But what about parsing complex experimental medical data? Here, you enter the realm of benefit and damage, and those concepts are not universal at all. What might be incredibly beneficial data for a specialized medical researcher could actually be highly damaging or confusing for a patient trying to self-diagnose at home. Benefit and damage depend entirely on the specific user, their immediate context, and their ultimate purpose. So the crucial takeaway is that to properly evaluate safety in a way that actually matters to a real human being, the AI needs what's called a user-specific evaluation reference. Basically, it needs a concrete baseline that defines exactly what constitutes a benefit or a danger for you, right now, in your specific situation. And current general-purpose LLMs, they completely lack this. Why? Because they scraped the broad public internet. They didn't scrape your personal life context, which brings us to a huge misconception about personalization in AI. Let's talk about preference versus user correction. Simply giving a thumbs down to an AI prompt does not solve the safety issue. It's kind of like slapping a fresh coat of paint on an engine that's completely broken. If you tell an AI, I don't like this answer, you're just expressing a preference. You're tweaking the superficial flavor of the output. But user correction, that is an entirely different beast. True correction means opening up the hood and saying, look, the way you classified this situation is fundamentally a danger to my workflow. You have to change your underlying semantic interpretation. Preferences just scrape the surface, while true user correction fundamentally rewrites the model's logic for that specific user. And current features just don't go deep enough to rewrite those gears. Armed with that understanding, we can directly confront the prevailing industry architecture. And that is the multi-agent safety myth. Okay, so throwing more agents into the mix absolutely does not magically conjure up those missing personal references. Think about it for a second. If 3 AI agents all evaluate a prompt and they happen to agree, it doesn't mean they've discovered some absolute truth. Usually, it just means they read the exact same textbooks during their initial training, so they share the exact same blind spots. They're basically just homogenizing the error. Sure, if the agents disagree, it's a super helpful red flag. It signals an unknown, but it is absolutely not a foolproof safety net or some perfect detector for rare black swan events. While having AIs cross-verify each other is a fantastic research method, relying on it as a 100% safety guarantee, that is a very, very dangerous illusion. A super common trap in the tech industry right now is slapping hypothetical band-aids on deep structural cracks. You'll hear engineers say, well, we just need to build an output stability module, or let's just add a dynamic user reference generator. The research warns us strongly against this. Saying you need a module for a problem is literally just renaming the problem. It doesn't solve a thing. Until you have concrete, independently verifiable mechanisms to actually achieve stability, you're pretty much just holding a fundamentally broken system together with theoretical duct tape. So if multi-agent systems aren't the silver bullet, where do we go from here? Well, we need a major paradigm shift. Enter the bespoke AI solution. To build truly trustworthy systems, the architecture has to evolve through 4 specific steps. First, it needs robust unknown detection, the ability to reliably flag when the system is operating outside its confidence zone. Second, continual learning. The system has to update its understanding in real time, not just wait around for the next massive training run. Third, and honestly this is the hardest but most crucial leap, user semantic correction. The system must allow the user to reach into the gears and fundamentally alter how the AI interprets benefit and damage for their personal context. Only when those 3 rigorous steps are mastered can we achieve step 4, true bespoke AI, an AI tailored deeply, structurally, and safely to the individual. Which really leaves us with this final fundamental thought. The path to AI safety isn't about rushing to build a better evaluator or just piling more AI agents into a server room to check each other's homework. Before we write another single line of code, we have to answer this core question. What exactly should AI evaluate in a world of complex, subjective human contexts? And mechanically, how do we actually guarantee trust? Until we solve that, the multi-agent safety net is just an illusion. Thanks so much for joining me on this explainer, and keep questioning the algorithms.